This video is for sections 2.1 to 2.4 in your textbook, and we're just starting to get into forces and a review of forces. I'd imagine that you've seen most of this stuff in previous physics classes, but it'll be a good place for us to start. In this video, we'll talk about forces, adding forces, resultant forces, and then we'll do a quick review of some things to triangles. So for forces, what are important about forces? So let's say we have an eye bolt or something, and we have two forces coming off of this. So something's you could have a rope or something that's pulling this. So say we have F1 and F2. Let's see. So what are important about forces? We have the magnitude, so how much you pull on that eye bolt. That would be one thing that's important. So that's the amount of the force, also called the magnitude. What's also important is the direction that we pull. So the magnitude and the direction are what matters. If we only have the amount of the force, then we can't really figure out much about the problem and what's going on in the larger system. So we always want to think about the magnitude and the direction. And that's why we want to get into vectors and develop an understanding of vectors, because vectors have both magnitude and direction. So we're going to start by talking about just adding vectors. So when you add vectors, you have a couple of different methods of doing that. But basically just to get an idea of what we mean by adding vectors. So let's say we had those two forces on the previous page. I'm going to grab those. So we have these two forces, and we were curious what the resultant force is on that eye hook. So what we want to do is we want to add up both F1 and F2 so that we get that resultant force. So a way to add those forces is you can do the sort of tip to tail method. So we can take F1, so let's draw F1, and then we can add F2 to it. So we did this vector, and then we put the tip of vector F1 to the tail of vector F2 and drew that one. And then what we're interested in is that resultant vector, that F, we'll call it FR, is the resultant vector. So we're basically just adding those two vectors together to get that resultant vector. We can figure out how to, or some different ways of adding vectors. There's the triangle method. So we basically draw this triangle, and then assuming we know something about, say, this angle and maybe this angle, we can put those angles in here. We know some of the things about the magnitudes, and then we can figure out how to solve it. So that's the triangle. That's one way, is the triangle method. Another way is the parallelogram law. Basically with that, so we have our F1, and we have F2, which is in that other direction. Then we basically just take, at the tip of F1, we draw a line that's parallel to F2, and then we do the same for F2. So this is parallel to F1. And where those two sort of parallel lines intersect is where that resultant force will go to. So that would be the resultant, or the parallelogram law sort of way of doing it. The third way is resolving forces. We can resolve each of the forces and then add the components. And this can be super helpful when we have more than two forces, and it's also super helpful when we're dealing with 3D, with stuff in 3D. But basically the idea of resolving the forces, let's go back to this, to the original eye hook. Let's see. Well, so we have our eye hook here. Basically what we'll do is we'll resolve each of these. We're going to pick sort of a X and a Y direction. And we'll resolve each of these forces along that X and Y. So this here would be the F2 of the X component, and then this is the Y component of F2, so we're just resolving that onto the new axis system. And then for F1, we can do the same. We basically take this one over, use a different color. So then we have F1 of Y in the Y direction, F1 in the X direction. And if we know each of those magnitudes, then we can just add those all together to get the resultant forces. So the resultant force would equal F1, or the X component of F1 plus the X component of F2 in the I direction plus F2 so that was F2 in the X, because we want to add up both of the X things. Then F1, 1 in the Y direction, plus F2 in the Y direction. And this is in the J direction. And that would give us the resultant force also. And I haven't mentioned the I and J. So the I and J are basically just telling us the I is in the X direction and J is in the Y direction. So just remember that I and J are in the X and Y. So you can resolve the forces. You could do it along different axes. It doesn't necessarily have to be X and Y, but that's just a way to sort of make sense of, break down each of the vectors, and then add them up together. I'm going to give you a couple of, so with both the parallelogram method and the triangle method, it can be helpful to understand triangles. So I'm going to give you a couple of reminders about triangles. So there are a couple of things that will be helpful. One that will be super helpful and make sure you understand are common triangles. This will save you a ton of time. These are used a lot in our textbook. But let's say we have a force that's up in this direction. It's 40 pounds is the amount of force. And we know, or they tell us that it's a 3, 4, 5 triangle. In the book, that 3, 4, 5 is all in italics. And let's see. This is the X direction. Going up is the Y direction. And if we're interested in figuring out and resolving that force along the X and Y axis, which you'll often need to do, you can do, so this would be that force in the X direction. and then this one here is that force in the y direction. So F of x is going to equal, and it's basically 3 over 5, so you can use that, times that force, which is the 40 pounds. So F of x is going to equal 3 over 5 times the 40 pounds. So that's 120 divided by 5. So that'll equal 24. So it's 24 pounds in the x direction. And so for F of y, we take of that common triangle, so the proportion will be 4 over 5. So the one going up and down, which is in the y direction, over 5. So 4 over 5 times that force. So that equals 4 over 5 times 40 pounds. F of y equals 32 pounds. The other way that they'll represent triangles is just with angles. So this isn't really a special method. So just angles and forces. So if we did that same, or had that same force, so it's 40 pounds. Instead of them giving us the common triangle, they could just tell us that that angle is 53.1 degrees. And that's the x and the y-axis. And we're interested again in resolving that force. So we want to know what F of x is, and we want to know what F of y is. For this, we use the law, or we use sine and cosine. For me, I always do the SOHCAHTOA. I don't know if y'all probably have some different tricks that you use. SOHCAHTOA. And basically, what the SOHCAHTOA says is that sine, so the first S, sine of whatever angle equals opposite over hypotenuse. Cosine of that angle equals adjacent over hypotenuse. And tangent of that angle equals opposite over adjacent. You have to be careful with this. Well, yeah, just make sure that you pay attention to what angle this is. So for the 53.1, the adjacent whatever line would be this F of x, and the opposite would be the F of y, which we could rewrite over here. So just remember to pay attention to where that angle is, because it matters. If that angle was up here, then it would up on this one, then that would change things. So let's figure out what this one would be. So it's the same, so we should come to the same answers or same conclusions. But so F of x is going to equal, or we'll just do the same as what we have there for the things. You get used to doing it sort of a shortcut way. But so the cosine of that 53.1 degrees, cosine of 53.1 degrees equals adjacent. So adjacent would be that F of x over the hypotenuse, which would be that 40-pound force. So F of x equals 40 pounds times cosine of 53.1 degrees. And that should come out the same as the other one. So let's see, 53.1 cosine times 40. We get F of x equals 24 pounds. And then F of y, or then we'll do the same thing for sine. So the sine of that angle. So sine is opposite over hypotenuse. And this one, sine is opposite, would be that F of y. That equals Fy over the hypotenuse, which is the 40 pounds. So now we're going to get that magnitude of Fy equals And it's 40 pounds times that sine of 53.1. And that comes to 32 pounds. As you get used to doing these, you'll just go straight to f of x equals 40 times cosine of 53.1 of that angle. But for now, it might be easier just to write it out this way. So those are helpful for your review of triangles. Some other things that you may need later on is the law of sines and cosines. So I'll give those to you really quickly. So law of sines. For this, let's say we have a triangle. We have something like this. B is the length of that side, C and A, and we'll like alpha is just that symbol. Beta is the angle here between A and C, and then gamma is the angle between A and B. For the law of sines, basically we have A over the sine of alpha. So A over the sine of the angle that's across from it equals B over sine of beta. So that's this one over the sine of the angle opposite. And that equals C over, you should be able to figure this out now, C over the sine of gamma. So that's the law of sines that can be helpful for you. And then the last sort of review thing is the law of cosines. The law of cosines, so using that same triangle. So let me write it again. Doesn't look exactly the same, but it's okay. For the law of sines, c squared equals a squared plus b squared minus 2ab cosine of gamma. And gamma is the angle between a and b. So that can also be a helpful one. If you need a more thorough review, there are a lot of resources online. I think I provided one for you from the Khan Academy, has some good ones. I recommend going and actually reviewing this, make sure you understand it. If you understand this, it'll make a lot of the stuff later on easier. So I guess the last thing, sometimes it can be helpful to figure out or a lot of times you'll need to figure out the magnitude of a force. So you can use this law of cosines to do that. If you have resolved your force, so let's say, go back to one of those earlier forces, and you've resolved it, let's see, this is the x in the y direction, and you've resolved your force along this, so that's F of x, we'll call that main one the resultant force, and F of y. To figure out that magnitude of F, so that magnitude of F sub r is going to equal the square root of F of x squared plus F of y squared. The reason why that works that way is because A and B, or because x and y are 90 degrees to each other, the cosine of 90 is just 0. So if we look back at that equation for the law of cosine, so c squared equals a squared plus b squared minus 2ab cosine of gamma. If that gamma is 90 degrees, which it is here, this term just goes to 0. So c squared equals a squared plus b squared. If we rewrite that for our equation, that's f of r squared equals fx squared plus fy squared. So f of r equals just the square root of f of x squared. So it's just a special case when you have things that are 90 degrees from each other. And when we resolve things to x and y axis, we intentionally make it 90 degrees to each other. So this is just a simplified form for that. for the magnitude. Let's do one quick example. So let's do an example with the resultant forces. So let's say we have a soccer ball or something, and we have two forces acting on it. One's in the x direction, F1 equals 3 pounds. One is in the y direction, F2 equals 4 pounds. And then we're interested in the resultant force. So we're interested in adding those two together. See, that's F1 drawn again. And then we're interested in what that FR would be. Could also do the parallelogram method to see that. So let's do this. We could do it a number of ways. Let's do it with resultant forces just to get a practice of that. So F1, let's write that in Cartesian format. So F1 equals 3 units in the I direction, so that's the x direction, plus 0 units in the j direction, and those are pounds. See, F2 is 0 in the I direction because it's going straight up, plus 4 in the j direction, and that's pounds. So that resultant force is just going to equal, we just add those two together, so that'd be 3 plus 0 in the I direction, plus 0 plus 4 in the j direction, in pounds. So F of R equals 3I plus 4J pounds. That admittedly is a pretty easy one. You could have probably just figured that out without doing the resultant forces, but just to show you how that works, the magnitude of that force is just going to equal the square root of 3 squared plus 4 squared. So that's the square root of 25, so that equals 5 pounds. So we could have done that a couple of different ways. We know that it's a 3, 4, 5 triangle because we know that this is whatever, 3 and 4 and then 5. So we also could have used that. We also could have just, from looking at it, known that the resultant force is going to equal 3I plus 4J. But I just wanted to give you a really simple example. These resolving the forces is helpful when you have more than two forces, or if you're dealing with 3D forces, which we'll get into in the next section. I think that's it. We'll also have some example problems in class, and just check out everything online. And now it's Canvas to see some additional resources. And that's it. Thanks.